So, just a small amount about my own background. I went to Princeton University in 1980, more than 40 years ago. Then I went to University of Wisconsin. My background is in mathematics. After Wisconsin, I went to China for 5 years and taught at different universities there. I also got married in China. You can see my wife. I can't tell if you can tell she's Chinese. We have 4 children. My son got married last November. Joseph, Esther, Lydia, and Rebecca. And they're all big. Okay. So, after I came back from China, I joined Motorola. You may know this company. They used to make phones and electronics. And I worked as a systems engineer for wireless communications for 12 years. After that, I joined my current institution, Texas A&M University, Central Texas. And I've been there since about 2010. Around 2013, I started coming to Africa. My first trip to Cameroon was 2014. I went to Amaroa and taught at ESS, Institut Supérieur des Sahel. Okay. Then, because of Boko Haram, I moved to Ngaoundéré, and I taught at NSAI in Ngaoundéré. So my first trip into Cameroon was about 10 years ago. Just about 10 years ago. Since that time, I've made several trips to Africa. You can see here in Nigeria, I've gone to University of Lagos, University of Ilorin, Covenant University, and I've taught at different schools. I've also been to Sudan, Al-Zam Al-Azhar University, and visited there several times. So I have some experience meeting different challenges. And I know that the African situation is somewhat different from the situation in the U.S. So I hope that we can adapt this course to be useful to you. What my purpose is not just to speak and convey information, but to have some interaction. So that's about me. Let me get started with the course outline. And let's see where we are. Okay, should be here. Let's make it big. That's very good. It's very clear. I'm happy to see that.
Good.
Okay, good. So let me just, we can do it this way. All right. So it's very fortunate for me because I will be teaching the same class in US at the same time, online. So we will have some competition. We'll see if you can do better than my US class, or if my US class does better than you. So we will have a nice competition. So the course has 2 main objectives. I just do from here. Has 2 main objectives. So it's to give you an understanding of the methodological foundations of machine that are common to all machine learning algorithms and techniques. Machine learning is a very, very big subject, and we cannot cover everything. However, there are some basic methods and concepts that are common to all machine learning algorithms. And also to give hands-on experience. So I really want to do a great deal in class with hands-on. How many people have a laptop or a system? All right, good. So we certainly have enough. If we have one, it's good to have 2 people work on one system. I find that that's a very good way to do it. And I'm very happy that you have desks that are just perfect for this. So after some classes, you will bring your system and we'll do some Python programming in class. The course is mostly oriented around programming. So we will get into that a little bit more. Okay. So these 2 things, get the basic method and also to have some experience implementing. Okay. All right. So after this course, I hope that you will be able to learn new machine learning techniques. Now, this is a mathematically based course, so you do need to know some basic mathematics. I hope that you've had all these things. We will spend the first 2 or 3 classes going back over elementary linear algebra. If you know what a matrix is, matrix and vector. So we will be talking about these things. But after that, we will get more into the programming aspect. Now, you can copy this down. All of the course materials will be here. So if I copy this link and go to my browser, I could just click on it, but let me copy it. Copy, and I'll go to my browser. And hopefully it will work. A little bit slow. And I'll paste it here. And I don't know why it says, oh, here we go. Okay, good. So you will see several items here. And you should be able to download these items from here. One folder here has Hasiaskar Machine Learning PowerPoint. This is the center of the class. My class presentations will be from here. I'll explain the name Hasiaskar in a moment. All right. The document that I showed you is this one here. Mathematical Foundations of Machine Learning. That is this document here that I'm going through. So, and then I also have some linear algebra exercises. So you will be doing these exercises during the class. So all course materials are at this link here. Please copy down. Or take a picture, even better. All right. So after some time, you will need to install some software. Jupyter Notebook. The best way to install Jupyter Notebook is to go to anaconda.com. Here's Anaconda here. I will talk about this later, because we're not going to do this immediately. Most of the course will involve you programming using Jupyter Notebooks. And I will show you some example later of Jupyter Notebooks. So first, before we begin the technical subjects, I want to explain what is machine learning. Maybe you've heard. Who has heard of machine learning? Okay, a few people. Okay. All right, so I need to get you interested in machine learning. Why should you learn machine learning? Why is it important? Why would you even be interested to learn? So let me go to the introduction here, and we'll start the presentation. All right, so you can see the name again, Hasiaskar, Dr. Mehrdad Hasiaskar. He is a professor of computer science at University of Western Cape in Cape Town, and he is a colleague. So we worked on this together. I'm using his presentation because I think it's a good one, and it also gives perspective from a computer science perspective. Now, I'm a mathematics person, so I have also recorded some presentation. You can go here if you want. These are on YouTube. And I would recommend especially the second one. This is not necessary, only if you are interested. All right, so what is machine learning? Machine learning is concerned with software, algorithms, and systems that learn from data. You can see a timeline here. In the 1950s, people started looking at artificial intelligence. Maybe you've heard more about artificial intelligence. So this is the computer doing things that people usually do. Then in the 1980s, people started developing machine learning. So I will explain the relationship between machine learning and artificial intelligence. Basically, if artificial intelligence is the vehicle, then machine learning is the engine. Machine learning is what makes artificial intelligence work. Then after machine learning, maybe 10, 15 years ago, they started to have deep learning. Deep learning is very powerful and has now become one of the largest areas in technology in the developed world. Many, many jobs, many, many opportunities in deep learning. I don't know if anybody has ever used ChatGPT. Has anybody used ChatGPT? Okay. All right. So I think people know if you haven't used ChatGPT. Okay. So I use ChatGPT. Yeah. Okay. So ChatGPT is based on machine learning. Okay. So maybe that will help you be interested in machine learning. This one aspect of machine learning, natural language processing. It's called natural. So there's other aspects of machine learning that I will get into in a moment. So it's a little slow, so we won't look at that. Okay. Whoops, where are we? Okay. Okay. So you can see the progress, and who knows what will happen next. Okay. So what is machine learning? So this definition says, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Right? So this means that the machine is something like a human being. You ask a human being to do something. Go to the store and buy milk. Right? You tell them the basic idea, and then they will learn how to do it. Right? They learn how to go to the store, they learn how to get milk. Okay? So it's not explicitly programmed. So we can be more exact and say, here is a learning problem. A computer, let's see if I can do this. Oh, is it hooked up? It should be hooked up. Let me try again, sorry. Let me use the other one. All right, that's good. Okay, there we go. Okay, good. Okay. So you see three parts of the learning task. You have experience, and you have a task, and you have performance. Experience, task, performance. So you can break a learning task into three parts here. There's the task. That's what is needed to be accomplished. So here's one example. Determine whether email is a spam. Okay. Now, experience. To develop a computer program to detect whether email is spam or not, it needs to have some example emails. It needs to have some example of spam and not spam. So after the computer has looked at many emails that are spam and not spam, and then it will become better, and it will become better and better at telling which email is spam and which email is not spam. Okay. So you want the probability of detection to become better and better. Right? So this is basically the outline of a machine learning process. You have a task, the computer has some experience to become better, and the performance of the computer should become better following the experience. Okay. Right. So here's another one. In a medical application, if you have a tumor inside the body, and you have some kind of X-ray, so you have an image, right? And you want to tell if that tumor is malignant, right? Malignant is dangerous, or benign. Benign means it's not dangerous. So the task is the detection. Is it malign or is it benign? Now, previously, you need to have a trained technician to tell whether the tumor is benign or not benign. Then the experience is a bunch of images of benign and malignant. Now, you need to give the computer images that are labeled or identified. Okay. How would you teach someone to distinguish between benign and malignant tumor? Well, you give them a lot of pictures of benign and a lot of pictures of malignant. And you say, This one is benign, this one is malignant. This one is benign, this one is malignant. After some time, you can tell the difference between benign and malignant. This is the same way with machine learning. So over time, after much experience, the computer should become better and better. Now, how does it learn? How does it take these images and learn to distinguish? Well, that's the machine learning. The machine learning has some techniques. So, in traditional programming, you have data and you use the program to get a result. Okay? In machine learning, you have data, and instead of result, I would actually say machine learning algorithm. Okay. So you have data, and you perform a machine learning algorithm, and this will have a program. The result will be a program to process additional data. So that's what machine learning does. So let me also draw a connection between machine learning and statistics. So in fact, machine learning is very similar to statistics. What does statistics do? Statistics takes data and develops a model. For example, if you want to do some regression, suppose I have some data, and here I can have So I have some data. Maybe this is weight or height and weight. And then we can say maybe this is weight versus height of 16-year-old males. Okay. Now, if you have several 16-year-old males, each 16-year-old male will have one data point. Right? One 16-year-old male may have, I don't know, let's see, might have a height of 180 and have weight, I don't know what, maybe 90, right? So one male may have this data point. Different males may have different data points. So you're going to get a bunch of data points. I think you've seen diagrams like this. Have you seen diagrams like this before? Okay. Where you plot some data. Okay. All right. So, if we want to predict, okay, given the height of male A, I want to predict the weight. Now, how will I do that? Suppose I know the height of male A. Okay. So here's male A. This is his height. Okay. So what prediction will I make of his weight? Do you think that this is a good prediction? Is that a good prediction for his weight? Okay. Here, let me give you 3 predictions, and I will say, so suppose, I'll predict, this is prediction 1, this is prediction 2, this is prediction 3. Okay, so how many people say the prediction 1 is the best one? How many people say prediction 2 is the best one? Okay, you have a few people. How many people say prediction 3 is the best one? Okay. Well, I think I agree with the people for prediction 2 because If prediction 2 is true, then the data point is here. It's inside of the data. Now, what's the best prediction? The best prediction would be you take this data and you form a model. So this would be a linear model. And you would use this linear model to make a prediction. Right? If the height of male A is there, then I would predict this value for the weight. If the height of male B is here, then I would predict this value for the weight. Okay. So this is the same kind of thing. I have data that I'm learning from, and I use the data and a mathematical algorithm to form a model. And then I use my model to predict. This is the same thing that is done in machine learning. Take the data and the algorithm and perform and create a model. But in fact, machine learning and statistics are very, very close. And almost you can say they intersect. So the ideas are very similar. So why has machine learning become so important? Well, because now we have so much data, and computers are so fast that we can use new techniques to develop better models. So that's why we can do things like ChatGPT. So much computer power can pretend to be. So here, let's see. Suppose I say, tell me the nicest thing about Yaoundé, Cameroon. Okay. So I'll have to wait for it to answer. But you can see this is not a person, this is some computer thinking, and it will give me an answer later. Okay. So more hardware, better algorithms, more data. So that's why. So what are some practical cases of use? So you can see if you're interested in business, all of these are very, very important in business, especially online business. Now, online business may not be so developed in Cameroon. Has anybody heard of Amazon? Does anyone? Is Amazon in Cameroon? Is there something in Cameroon like Amazon? I think there is something like Amazon in Cameroon. But in U.S., many people don't go to the store. They just go to their computer and shop. Here, I'll show you Amazon. Okay. Oh, here we go. Oh, this is very nice. In Yaoundé, so this is what the computer tells me. Okay. So the computer likes Yaoundé very much. One of the nicest aspects of Yaoundé is a vibrant cultural scene. It's known for its rich cultural heritage. You can experience traditional music, dance, and art. And it has museums and theaters, and so on. So ChatGPT can give me information if I want to visit Yaoundé. So let me see about Amazon. Oh, all right. Let me see if I don't know if I don't have her. Let's see if this works. Okay, this may also take some time, but we'll see if that works. So you have spam detection. If you have some false email, fraud detection, someone pretending to be someone else, video surveillance. You have a home and you want to make sure detect whether someone is going to steal from your home. Rather than have a person always watching, you have video, and the machine learning can detect whether there is some activity that is strange. Okay. Access control. If someone wants to get into a room or an area, the machine learning can identify this person. Maybe using a fingerprint, maybe using a face, maybe doing a scan of the eye. Okay, malware detection. If you have, it can tell if there's a virus, computer virus. Abnormal detection in crowds. Okay, and maybe it says something that is happening in a crowd. So the machine learning can tell the different parts of an image. So the machine looking at this picture can say what's inside the red box is a dog, or what's inside the green box is a hat. Machine learning can read writing. One of the first applications of deep learning was to read numbers. And this was used in the United States Post Office and became very useful. It can also read the plate of license plates of cars. So if some car has an accident or is speeding, if there's a camera there, the machine learning can identify the license and identify the person. Okay. Financial trading. So machine learning can be used to detect trends. Energy optimization. So the machine learning can recognize patterns of energy use and then change the energy source or the way the energy is routed to reduce the energy consumption. Healthcare. This is a very, very big area about to do some medical diagnosis. You give the machine learning algorithm information about the disease, and then the machine learning algorithm may recommend some treatment. Oncology, this is the study of cancer. So it may look at different aspects of the person's family history or health or blood pressure and temperature and so on, and it may design some treatment especially for each patient. Remote patient monitoring. You may have an old person who sometimes will have heart attack. You can tell if the person is going to have a heart attack. The machine learning can analyze the ECG and tell if the person is going to have some episode. Epidemics. If there's going to be some disease, the machine learning can look at some data about the incidence of disease and predict if the disease will be coming on. Okay. So here's an example of an image. You can see that the machine learning may be able to identify the tumor or something that's not a tumor. Now, in the actual image, you don't have different colors. The color was added by the machine because it identified this as a tumor. Right? So, as we said, artificial intelligence, you have ChatGPT, you might, in US, often if you want to get, for instance, here you have Camtel, you have Orange, you have MTN. If I want to get some help from my phone company in US, I will call a number and I will talk to a machine. And the machine will help me get what I want. I won't be talking to a person, I'll be talking to a machine. Here, when you call Camtel, nobody will answer. But there, if you call, then you will get a machine. Okay. For sales and marketing, so this says that there are different aspects of reaching the customer. First, you want to reach the customer. Then you want the customer to act. Then you want the customer to convert and develop a habit of taking your product. And then you want to engage, you want to keep the customer using your product and not some other product. So there are different things you need to do at different stages in the interaction with customers. Like to reach the customer, you need to send your advertisements to the right place. You need to respond when people show some interest. When people are thinking of buying, you need to make the buying experience good for them. You can recommend the right product to them. To convert, you want to see whether the customer is continuing to use your product and engage. If the customer stops buying your product, you want to make some change to bring him back. All of these tasks can be helped using data, and machine learning algorithms can be employed to develop the best strategy. Recommender systems. If someone is interested in movies, they can tell you some things about movies that they like. They can tell you other movies they like, and then the recommender system will recommend another movie that's similar, and based on past data of other customers. By natural language processing, the big example is ChatGPT. Self-driving cars. In U.S. now, there are self-driving cars in some places. I think some of these applications may not be suitable for Cameroon. I doubt that self-driving cars will be popular in Cameroon because all of the taxi drivers will not like this. So you have different applications for different societies. So some of the applications that I said may not work for Cameroon, but I think that Cameroon or other African countries can develop different applications that will be useful. Multimedia, people now make movies using machine learning. They do animation, they do other image enhancement, and other things like that. So machine learning also relates to other aspects of technology. You can see machine learning here. I mentioned before that machine learning is like the engine for artificial intelligence. So you can see machine learning is inside of artificial intelligence. So there are other aspects. Now, of course, data is the center. You need to have data to fuel your machine learning algorithm. And to make data effective, you also need to have good databases. You need to have some way to recognize good data, because you have to decide what data you're going to give your machine learning algorithm. Here they put statistics on the side with machine learning. I don't really agree. I think statistics and machine learning should be overlapped together. So machine learning is part of a large web of different types of technology. Three main categories of machine learning. There's supervised learning. So supervised learning means that you have different data that you've identified already. So maybe I can give you an example of supervised learning. Where are we? Okay, so let me use my same example here. I'll do height and weight. Okay. And let me take, so I'll say that the blue data, this may be 16-year-old males. Okay. But suppose also I have 16-year-old females. So I'll make that data be a different color. Make that red. Okay. Now females will tend to be shorter and possibly weigh more. So the height will be shorter and the weight will be more. So females may be, let me make a different color here. Okay. So these may be females. So this is 16-year-old females. So suppose I have data from a person here, and I know their height and their weight. So I know a person is there. Is that a male or a female? So it's a little bit hard to tell because there are many males close by or there are females close by. Now, if I know the height and weight of this person, I think most likely that's going to be a male. Or if I know the height and weight of this person, that's most likely to be a female. So the supervised learning means you give data for males, data for females. You use this to develop a model, and that model will tell you how to predict which is a male, which is a female. So that's supervised learning. So that's why the picture looks like this. You have some data that's blue and some data that's red. And you want some way to divide between the two types of data. That's supervised learning. And we'll see a lot more of supervised learning later on. All right. Now, unsupervised learning means that I have some data and I want to find some pattern. I don't know what the different kinds of data are. I want to look at the data and divide it into different patterns. Now, reinforcement learning means that I have some process. I may play some game like chess or this game. I don't know if you know this game. This game is called Go. It's a Chinese game. But after playing many times, playing the game many times, the machine will learn to do better and better. So that's another kind of machine learning. There's another kind of machine learning which I showed there is regression, which will predict values. And during the class, we will be looking especially at supervised learning and regression. The other ones are similar. Right. So here you see different applications for the different types of machine learning. For unsupervised learning, you have these different applications. If you have supervised learning, other applications. Reinforcement learning, you have other applications. I think we don't need to go to this in details. Now, here you can see many different categories. There are many machine learning algorithms. We cannot talk about all of these. Now, in some classes, people will introduce many different algorithms and say a little bit about each algorithm. I don't think this is good because you should learn one algorithm well. Yes, come in, please. And learn one algorithm well, and then you can learn other algorithms well also. So it's like playing an instrument. If you play the violin, you should play the violin well, and then you can learn to play another instrument. So in this course, we will focus mostly on 3 different algorithms. One for regression, one for supervised learning, and then one for deep learning, which is also a class of supervised learning. So when you use machine learning, there is a process. So for machine learning, in machine learning, you develop a pipeline. Okay. And what do I mean by pipeline? Pipeline is something like this. Pipeline means a way to go from your data. You go from data to the machine learning model. Okay. All right. So here you can see here, and we can also relate this to we had task, experience, and performance. So the experience comes here. This part is the experience part. And then the performance part is here. And the center is here. So, what is this pipeline? First, you start with raw data. So this is data that is collected maybe from the internet, or it's collected from people taking data. But the raw data usually needs to be processed. So you need to remove some bad data. You need to format the data in a good way. So you need to prepare the data before it can be used to learn. Then you apply a machine learning algorithm. So you need to know the different possible machine learning algorithms. So you can apply more than one. Usually you will try 3 or 4 different algorithms to see which is the best one. Then you apply that to your data, you get some candidate model, and then you go back and use your candidate model to retrain the candidate model. Then after that you get the model that you are actually going to use. So we will see this process during the course of this as we go through the course. So this is another representation here. This one here is your experience. You start with your training data. So this is the experience. Okay. And then the model is the task. And then here is the performance. Okay. Or you can say the performance comes when you evaluate. So you start with data, which is your experience. You have a task which determines your machine learning algorithm, and then you evaluate your performance. And I think that's the end of this presentation. I might as well just keep them. All right, so, I think you all want to leave, but I'm supposed to be here until 5 o'clock. So, what should we do? Should I give you 5 minutes and then we continue? Is this what we do? Okay, 5 minutes. All right, it's 4:16 now. So come back at 4:21. Okay. So I looked up laptop. You can see I looked up laptop computers, and it gives me a list of several laptop computers here. Now these are all different people selling their computers online. So I can connect to these different sellers through eBay. So you can see that there are many problems here. Someone can list a computer and they take your money and then they go away, right? Or someone can say they pay money and they don't actually pay and they get the device, or the device may be defective. So all of these aspects can be helped by machine learning. You also need security. So you want to detect if people are doing some kind of fraud. So to make this kind of online selling work, you need to have some machine learning to monitor the process. I'll show you another website you may not know about. It's called Airbnb. Now, when I came to Cameroon, I didn't have a place. I found my place on Airbnb. I didn't go to a hotel. I found a private room using Airbnb. So I can show you if this works. Okay. So you see, it gives me some different places I can go. So I'll just say Yaoundé, and let's see. Suppose I want to check in 24, and I'll check out on the 6th, and then I can search here. And this again may take some time, so I can come back to this. But it will show me different places that I can stay. And these are not hotels. These are places where people are offering their rooms to stay. So you can see. Actually, I think this is the one that I went to. Yeah, this is the one that I went to. So I go here. It will show me the room. It helps me connect to the person. I can pay online. Everything is arranged online, and it works very well. So, where are we? Right. So I mentioned that this course also has some mathematical background. So I need to start doing some mathematics. So I hope you can. This may not be the most interesting part of the course, but it really is necessary for you to understand the rest of it. So let me go to the next presentation. And that's here. So, slideshow. All right. So, a matrix is an array of data. Now, you can say a matrix is a table. So here we have a matrix. We say this has 4 rows and 3 columns. In French you say ligne, right? And colonne. But always a matrix will have 2 dimensions, the rows and the columns. Now it's interesting here that these numbers here all are much larger than these numbers and these numbers. Probably these different columns use different types of data. Often you will put different types of data in different columns. This might be temperature, this might be date, this might be altitude. Usually we use large letters to denote a matrix, and the dimensions are, you always list the rows first and then the columns. So this one is 4 by 3, this one is 2 by 5. So when you want to indicate the entries of a matrix, this is how we do it. You use subscripts to indicate the different entries. If I want the entry in row 3 and column 2, I would call that subscript 3 and subscript 2. So this is an easy way to identify. So let me ask you, if you follow this, is this? I don't know why it's not letting me do pen. Why not? Why won't it let me do pen? So why is it not letting me do pen? Huh. All right. Well, let me grab it then. Sorry. I'll put it here. Sorry. Let's just do this. Sorry, I'll go here. Insert screen clipping and take this. Okay. All right. So that's my matrix A. So my question is, what is A12? All right, let me give you 3 possible answers. Let's say 70. B is 5. And C 4. D 10. Okay. How many people say 70? How many people say 5? How many people say 4? Okay. How many people are sleeping? Okay. In fact, 4 is correct. Okay. So I think you understand this. So what is A33? Which one? Is it A? B? C? D? Okay, so what is it? It's 8, yes, okay. What is A34? Sorry, I should use the small letter. What is A34? Yeah, it's not there. Right? Because if I go to the 3rd row, there is no 4th column. All right, so I think you have this one. Okay. All right, so, all right. Now, vector is a special case of a matrix. Here we have a vector that's a column. You can have a column vector, or you can have a row vector. Now, in this presentation, vector is always a column vector. Okay, so when we say vector, we will mean a column vector. So the number of columns is 1, so we can always write it as n by 1. Okay. Vectors use small letters, and you have different dimensions. Since this has 4 rows, the dimension of y is 4 by 1, dimension of a is 3 by 1. In this case, you only use 1 index, because you don't need an index for the column. All the entries are in the same column. So you can see y1 is 21, y4 is 53. Now, how do you add and subtract matrices? In this case, it's very straightforward, right? If I want to add 2 tables like this, I just add the numbers in the same place in the table. So this 12 here comes from this 4 and this 8. So The numbers in the same position add to give the number that's in the sum. So, if the dimensions don't match, you will get an error. So we have this minus this. Okay, so let me just show you a little bit how this is going to work here. If I go to my Google Drive and I go to New and I go to More and I say Google Colab. Right. So I'm showing you ahead what kind of programming we will be doing. And hopefully this is going to work. Just a moment. Maybe I'll do this differently. I think I'm going to do it differently because it's very slow. So I'm going to do on my computer instead. So I mentioned to you that the type of software that we will be using is called Jupyter Notebook. So this is one way to start Jupyter Notebook. Okay, so I'll make a new one. Let's see. I'll make a new file. And this is what Jupyter Notebook looks like. How many people have used Jupyter Notebook before? Okay, good. Okay, a few people. How many? No, about 5 people. About 5 people. Okay. All right. So. Okay. So in Jupyter Notebook, you can type in some kind of text. And now I will write some program to do a matrix, matrix addition. Let me make this bigger so you can see. Okay. All right. So I'm going to write some program to do matrix addition. Okay. So first what I need to do is, so I have, for instance, if I want to add these 2 matrices, okay, so this one has 4 rows where each row has 2 entries. Okay. So how do I enter this? I also use the square brackets. So you can see the first row is 1, 4. First row is 1, 4. So I will put that here. So I think it's called A, and then here you have 1, 4. That's the first row. Second row was 4, 1. So I enter that this way. 4, 1. Okay. Next row, 2, 3. Sorry, it keeps going back there. Okay. And the last row was 3, 0. You see, the last row is here, 3, 0. Now, to put this together as one matrix, I need to put the bracket around everything. So this is how I will enter a matrix into my computer. And then here I can call this is going to be, I have to tell the computer that this is a matrix or an array. So I need to say NP. So we will do more of this later. I just want to show you how this works. So that's my matrix A. My matrix A is this matrix here. Let me call this matrix B. Okay. I'm going to do the very same thing. Right. Sorry. So B equals, and it's going to be an array. Okay. The first row was 5, 2. Sorry. Second row, 8, 0. Whoops, sorry, 8, 0. And you will certainly have a chance to do this yourself. Third row, 7 minus 3. Sorry. And last row is 6 minus 1. Okay. And I have to put a bracket around all of that. You see that it shows red. Red shows me that I'm missing something. So this is very smart. Okay. So then if let's say C equals A plus B. Then I can run this cell. I go to cell, run, and there's my C. So let's check it. 66121909 minus 1. So it looks like it gave the correct answer. Now here it shows that if I try to subtract something with a different size, I should get an error. So suppose I try to go here, and let me take out the last one here. Take out the last one, and then says, here I'm going to say print first matrix. Let's print A. Print second matrix. And then print B. And then you want to print some. Whoops, sorry. So let me go back here. I'll put the last one in again. Okay. So let's see how this works. So you can see that when I run my cell, it prints the first matrix 1 4 4 1 2 3 3 0. It prints the second matrix, and then it prints the sum of the two matrices down here. So I think this is easy to understand, right? I asked it to print the first matrix, it printed the first one, print the second matrix, the second one, and so on. Okay. Suppose I take out the last row here. It prints the first matrix, and then it prints the second matrix, and then it says error. And here it's telling me what's wrong. It says the shapes are not correct. So during this class, you will see this many times, I'm sure. You need to learn how to understand the message when it gives you an error. That's a very important skill in programming. So I just show you how we're going to translate this operation into programming. So we will be doing a lot of matrix operations. Another operation is multiply by a scalar or a number. So, for instance, I can write here, let's change this back again. Now, one very nice feature in programming in Python is that I can recover my error if I press Control-Z, and it will go back. Okay. So let me see if that's correct. Whoops, okay, sorry, I didn't finish it. I have to do this. Okay. Okay. All right, so everything is fine. Okay. Now, suppose I want to multiply the first matrix by 2, then I'll just do print. Sorry. Okay. I just multiplied this way. Okay. I can run my cell again. And you can see that my first matrix was 1 4 4 1 2 3 3 0. If I multiply my matrix by 2, it's going to be 2 8 8 2 4 6 6 0. Okay. So it's very easy to multiply matrices and add matrices in Python. It's one of the very good features of Python. All right, so let's go on. Okay. Now you can also multiply and add together, just like you multiply and add numbers. Okay. Now, matrix transpose is another important operation. In matrix transpose, you change the rows into columns. And you can see from the picture here. The first row here, if I go back, the first row here became the first column in the transpose matrix. The second row here became the second row in the transpose matrix. Third row became the third column in the transpose matrix. Another way to think about it is to flip the matrix. It's like you take a line and you flip the matrix around the diagonal. Another way of thinking about it. So the same way here. Whoops, sorry. Okay. Okay. So now matrix multiplication. Well, let me say one thing more about matrix transpose. Suppose I have a matrix A, and let's see. Okay. Now, if A looks like this, you can see that my A has, that's not very, I should make this better. Okay. So, what's the size of A? How many rows, how many columns? Okay. By the way, if I want the size of my matrix in Jupyter Notebook, that's also easy. I just type np.shape, and it will show me the shape. It gives me the number of rows and number of columns. So A transpose. A transpose. What's the shape of A transpose? How many? It's 4 by 3, right? Because every row becomes a column. Every column becomes a row. Now, suppose I want so it's going to be 4 rows. It's going to be 4 rows and 3 columns. Okay. Suppose I go down to row 3 here and column 2. What is the entry here? Now, remember that row 3 corresponds to column 3 up here. Right? And column 2 corresponds to row 2 over here. Right? So we see this 7 here. It's going to be 7. So I don't need to do everything. Suppose I have 1, row 1, and column 4. What number is that going to be? Row 1 and column 4, column 1 and row 4. Column 1 corresponds to row 1. Row 4 here corresponds to column 4 here. So it's going to be this number. So the way I can say this is that A, ij, or let me say it this way, sorry. Aij equals A transpose. You just reverse the different index. So that's how you can do transpose algebraically. All right, so matrix multiplication. So this one is a little bit more complicated. Okay. So to do matrix, and I will explain why matrix multiplication is this way. So matrix multiplication can only be done if the columns of the first matrix match the rows of the second matrix. So matrix multiplication does not mean that you multiply the same entry in the 2 matrices. Matrix multiplication is different. The 2 matrices have different sizes, but the number of columns in the first matrix must be the same as the number of rows in the second matrix. Okay. So you can always check by writing down the size of the matrix, right? 4 is the number of rows, 2 is the number of columns, 2 is the number of rows, 3 is the number of columns. So the 2 needs to match. The result of the matrix will be the rows here and the columns here. How many people have seen matrix multiplication before? Right. So maybe instead of trying to explain this, maybe I give you an exercise. Okay. All right, so get out your paper. Okay. Okay, I give you 2 minutes. Go. Some people can do, some people can't. So we can, we'll have a chance to do some practice. So, yeah. Okay, all right. So, yeah, you need to, this is something you need to practice. Okay, sure. So how do you think about this? And I think one reason people have trouble is usually people don't explain why you do matrix multiplication this way. All right. So how do you do this? If I want the first row, and I think this is the last, so if I want the first row and the first column, right? This is the first row and the first column. I want this entry here. How do I get that? Well, I have to look at the first row of the first matrix and the first column of the second matrix. So I have to look at the first row of this one, which is here. And then I need to look at the first column of the second matrix, which is here. Oops. And then when I do the multiplication, it's this one times this one, plus this one times this one. So what I'm going to have is 1 times 5 plus 2 times 7. So when you take the matrix multiplication, the row is the row of the first matrix. And the column is the column of the second matrix. Okay. So let me do a large example. So, whoops, sorry. I shouldn't. Okay. Suppose I have something like this. 1, 2, 6, 12, 3, 8, 15, 2, 1, 5. And then I want to multiply that by 1, 7, 2, 4. Let's see, what am I doing here? 3, 6. Okay. All right, now is this possible? Is this multiplication possible? Okay. Well, first you have to check, this is 4 by 3. This one is 3 by 2. Right? So these two are equal. That's good. The result is 4 by 2. Right? Now, suppose I want to get this entry. I want to get this entry. What do I do? Well, what I have to do is I need to go, so I want the fourth row here and the second column here. I need to go to the fourth row of the first matrix and the second column of the second matrix. And then I multiply and add. Okay. So the entry here is going to be 2 times 7 plus 1 times 4 plus 5 times 6. Okay. So we will practice. Okay. Okay. So I can also do this on my Jupyter Notebook just to show you how easy it is. So let's see. In this case, my matrices don't have the right size. So let me make another matrix here. So let me say D. Well, here, let me just copy this. And if I want to multiply by A, since A has 2 columns, I need to make sure that D has 2 rows. I'm just going to take off these last 2 rows. So A is 4 rows by 2 columns. D is 2 rows by 2 columns. So I should be able to multiply A and D. So now the way you multiply in Python is with this symbol, with the arrobas. Or we call this the @ sign. So if here, we don't need to see this anymore. So I'm going to comment all of this. Does it work? Whoops. It doesn't, I think I have to go down. Okay, sorry. No, is Control/ here? Okay, yes, okay, thanks. I forgot. Sometimes, why doesn't it? Okay, yes, I'll do that. Control/. Okay. So we don't need this part, but we do need the D. Okay. So now this will comment this part, and it will only evaluate A and D and the multiply. So I run this, and you can see that this gave me a 4 by 2 matrix, which is what I expect. So very easy to do in Python. But you still need to know how to do it, and you need to know how it's working. So if I just, so here he shows the same thing. So we'll just go through this quickly. Row 1, column 1 gives me the row 1, column 1 in the matrix here. So you can see this in the presentation. And I will try to fix this by Thursday. Now, what I will do is I will start a WhatsApp group. I can send you the link to the WhatsApp group.
Okay, that's good.
And then I can try to fix the link. But I think it's 5 o'clock, so should we stop?
We'll stop for today.
Yes.
Because students who have many more students are going to come for the class.
Yes.
Since at the beginning, I will stop at 5 o'clock, and then on Thursday. Hold on.